Ano po sir, dun po kami natapos sa magpapapanood po ng video about spectral matching po.
Yung resume ka na siguro sa 22, isend mo na lang ito sa GC, yung video. Yung
Sige
link.
po sir.
Ah,
Sige po. Wait lang po. So dun po sa selecting time histories, ang mahirap po kasi dito ay yung 'pag kino-consider po natin yung different time ng, earthquakes po. Dahil meron pong minsan ay ano po, nagkakaiba-iba and meron po tayong iba't ibang, kino-consider in selecting time histories. Katulad po ng magnitude, kailangan po ay, greater than 1 po ang magnitude and then the distance is within, more than 10 kilometers po. And then the faulting mechanism, more important for reverse or thrust faults, subduction zones, and sa spectral acceleration po ay within 20 to 30 at the natural periods of interest. And then po sa soil, kino-consider din po yung soil type and rock type po. Tapos and directivity effects if applicable pulse po.
Here are some things to look for. Plot the acceleration, velocity, and displacement plots for both the pre and post match the time histories. Make sure that the significant peaks in the governing motion aren't altered too much. 2. Make sure that the desired aspects of the ground motion are still there after spectral matching. 3. Compare the pre and post matching areas intensity plots. Make sure that the energy wrap up hasn't been signified altered.
Then po sa pag-analyze po ng ating, graph, ano po, 'pag po sobrang laki po ng ano po, ng ito po yung itsura nung, ah, parang hindi po, sinusunod na, I mean, yung pong hindi recommendable na i i-follow, then ito po yung sinusunod po. And sa ano po, sa katulad po nung sinabi namin nung last time, meron pong iba't ibang applications na ginagamit sa ah, paggamit po ng time history development, and ito po ay isa sa mga tip na na lagi pong pinapaalala na, be careful po sa paggamit ng iba't ibang apps dahil po minsan po may differences and may lapses po na na sa every app po, yun po. And hindi po kasi po 'pag ginagamit po yung mga app na yun, ay kailangan po ay may deep understanding po tayo sa paggamit ng app, and hindi po siya basta-basta nagagamit, gano'n po. Yun po, yun nga po yung pinaka-report po namin. Se-send na lang po namin sa group chat po yung ano.
Ilang minutes yung video? Kaya wala ko
Ano
siguro.
po, 30 minutes po.
Sige, sige. Sana. Kung time pa lang.
Ipe-play po namin, sir.
Ah,
Sige po.
So, okay, this is the interface of Seismomatch, and so, okay, this is the interface of Seismomatch, and it is very simple, just one-step process. In fact, two-step process. First, you define the target spectrum. You actually import a ground motion, and then just click on do matching. So let's open a particular ground motion file. So I click on open single. I can also go for open multiple, but let's first go to open single, one file. So here, when I click, I have to basically select the location of that particular file, and then some of the it will take me to default folder where some of the example ground motions are already available. But let me first open the first peer ground motion file which I have just downloaded. So let me first open this one. Okay, so let me give this path to the import wizard here. So here I have to first select all files, or here, and this is the file, the first file which I just opened. So when I click on open, a dialog box will be here, and it will preview me the file here, and then I have to fill this all the form and click OK. So this should be filled with with care, because if you perform any mistake here, the imported acceleration file may have some mistake. So the first line of the data is what? This is the first line of data, so I have to skip first 5 lines. Okay, so the first line is line number 6. This is the preview of that file, and if I want, I can also open that file in the notepad so that I exactly confirm each and every point. So if I see that here first 4 lines are the header lines, they are the information, and the actual data starts from line number 6, line number 5, sorry. So here also I have to actually put line number 5. So the data starts from line 5. First line is line 5, and the last line is, if I go to the preview and I click here on the last line, it shows me the line number, and that is 654. It have already read that last line, so 654 is last line. Then delta t time step, Time step is 0.02. So it by default says 0.01. So let me change it to 0.02. And then scaling factor should be 1. And then what is the format? I can directly go for the peer NGA format, or I can say multiple acceleration values per line. And then it will ask me how much which acceleration value per line. I will say 5 lines, 5 acceleration values per line. But here I can directly select peer NGA format, and it will directly read all the values correctly. Okay, so although I can give manually also, but it will read correctly. 0.02, 654 is the last line. First line is line number 5. And then I will just quickly uh, click OK. Okay. One more thing is that if I go for single acceleration value per line or any other value, other option, one thing is that, sorry, let me just correct that one. 6, maybe tier 1. Okay. Uh, the units should be very important, because here by default the units of G units are used here. So if your acceleration file have a different units, then you have to actually provide that, or you actually have to take care whether program is actually accepting the right units. So by default here you can see the acceleration is in G units, and my acceleration time history is also in G units, so it is compatible. So I click OK, and now it will import this acceleration file. So this is the acceleration time history. Currently, I just import it and I can see its time series. Acceleration can be numerically integrated to get velocity. Again, numerically integrated to get displacement. So I can see velocity and displacement also. I can see the response spectrum of this, you can say this ground motion. Currently, the target spectrum is not defined. Only this RSN 886 spectrum is available. Target spectrum is defined as step 2. And then mean match spectrum, obviously the matching is not performed yet, so this is also not available. I go back to again input output, and obviously this is the input ground motion, and after matching the ground motion will be shown here, and that will be output. Now let's go to second step, and that is define the target spectrum. I click on this button and I get this form, and in this form I have 2 3 options. One is code based spectrum, and there is a whole list of different codes which you can directly select. For example, ASC 7-16, you give the values of ASC 7-16 which are used as an input to determine the spectrum. So you give SS S1 and the soil class and the long period transition period TL, and it will plot the spectrum. If I modify the SS and S1, the spectrum is modified also. The second is that I use the spectrum from any other loaded accelerogram. For example, if I have a list of accelerogram or time histories which are already imported, I can go for this option and I select from that list that particular ground motion, and the spectrum of that ground motion will be used as a target spectrum for matching. So currently, obviously, I have only one ground motion imported, so that is the only ground motion. So the no other is being shown here. Damping can also be selected here. And the third option is the load spectrum from file. Okay, so you can load a spectrum, your own spectrum from file. So let me quickly generate, maybe in this folder, let me quickly generate in, a text file, and let's say that that text file is my target response spectrum. So I name it as target response spectrum, and let me just directly give without any header files, because when I open it again the same import wizard will come. So let's say I define a target spectrum 0.01 space, let's say the value 0.4G. 0.01 is the time period and 0.4G is the spectral acceleration corresponding to that. Then I say 0.2 second space, maybe 1G, then 0.5 second space 1G, obviously G should not be written here. Then I say let's say 1 second space 0.875G, then maybe 2 second space 0. Maybe 4G or 45G, let's say 3 second 0.25G, and 4 second let's say 0.1G or 15G. So this is my values for the target spectrum. So let me save that file, and now let's open it in this Seismomatch. I say open, and I go to the same folder and import this text file which I just created. So I go to all files and then click on target response spectrum, and click open. So the same similar kind of an form will open. So I say that the first line is line number 1, the last line is line number 7, scaling factor is 1, the period column is the first column and the acceleration column is the second column. So I click OK. So when I click OK, it read that file and it plotted that spectrum. Although it is not, obviously, I just guessed those values, so therefore its shape is not exactly how the typical spectrum looks like. But this is how you can define your own target spectrum. Okay. Currently, for the purpose of this demonstration, I just use a code spectrum and I use ASC 7-16 with these default values and I click OK. So when I click OK, the target spectrum is shown here now. And these are the spectral matching parameters. Minimum time period for which the matching should be performed 0.05, very small, and the maximum time period, let me make it 4 seconds, so it will match up to 4 seconds. Scale factor can be 1 and tolerance value can be 0.3 at minimum. Previously, in previous versions, in the academic license, it was allowed to reduce to 0.3, less than 0.3, but now you cannot reduce it from 0.3. So it means that the program currently will not exactly match, uh, but it may have a 30% error in the matching. So we cannot reduce that number from 0.3 unless we actually buy the program. Currently, I'm using an academic version of this program. When you download it from Seismosoft website, and you run it for the first time, it will ask you to register, and there is an option there for the academic license. So if you can email from your organization's email to them, and they will send you the registration number, and then you can register from this option, from this register license, and then you can use the program. So they give you the academic license for free, but they don't allow to reduce the tolerance from 0.3. So which means that there will be some small error in your matching when you perform matching using this program. So now, since we have already imported a ground motion, we have already defined the target spectrum, we can just now click do matching and it will start the process. So I click on do matching and now it is started the process. It may take maybe 1 or 2 minutes for one particular ground motion. So let's wait where it actually performs the ground motion spectral matching. And then after it complete, it will show the modified ground motion also and the spectrum of the modified ground motion also compared with the target spectrum. So now it is done. It says that there is an average misfit of 6.2% and a maximum misfit of 27%. So which means that during the whole 0 to 4 seconds, there is a point where the maximum misfit or mismatch between the modified ground motion spectrum and the target spectrum is 27%. But if you look at the whole range of time period 0 to 4 seconds, the average misfit is just 6%. So it took 12 iterations to actually perform this matching, and I click OK. So now this is the modified ground motion. Very first thing you can see here is that the frequency content may not be changed much because they look very similar, but their amplitude is changed 0.04 second, 0.4 G, but here 0.18 G. The peak ground acceleration was around 0.04 G in the original ground motion, but now after matching it is 0.18 G. But the frequency content may look very similar. But let's check now the response spectrum. Now we have the target response spectrum in the red line and the actual original ground motion with this orange line. Okay, so we see here that the orange line is much lower than the red line. So it means that we have to perform either spectral scaling or spectral matching. We have performed spectral matching already, and then we can go to the next tab where we actually see the mean matched spectrum. If we have more than one, we can check their mean. But if we have only one ground motion, then I can go for original accelerogram, these tabs which are here, then matched accelerogram. Okay. So now when I click matched, you see here that the orange line is almost overlapping with the red line. There are some mismatches here. For example, there is some mismatch here. There is some slight mismatch here also. Okay. If you see the comparison, you can see here that this bottom line is the actual acceleration response spectrum, and the green is the modified response spectrum. So that's how you can perform spectral matching. If you have more than one ground motion selected here, you can see the comparison here. And then these are the tabular values. This is for the original accelerogram spectrum, spectral acceleration, spectral velocity, spectral displacement, and this is for the matched ground motion spectrum. You can copy these tables to Excel and plot these graph yourself also. These can be simply copied. You can double click and right click and copy selection, and you can paste them in Microsoft Excel. So if you have more than one ground motion, this list can be checked, and you can select all the ground motions and see their comparisons like this. So it took around almost maybe 30 seconds to just match one ground motion. This is the mean matched. If you have more than one ground motion, you can check or uncheck them to actually see the comparison of their spectrum. These are the ground motion parameters. Comparison of ground motion parameters between the original accelerogram and the modified one. So you can see what are the values which are changed. Obviously, the peak ground acceleration is changed. Originally, it was 0.04, and now it is 0.18 after matching with the target spectrum. So similarly, you can also check other ground motion parameters also. The frequency content is also modified, and that can be seen, for example, in this some of the parameters which are related to frequency content. One of them is A max over V max. It is a parameter which is related to both the amplitude as well as frequency. So it is modified now, you can see. Similarly, some other parameters, the area's intensity and some other ones also are modified. So the last step is that how you export the modified ground motion after the spectral matching, and that is here, file, and then you have, I think first I have to save this project. So this matching project will be saved first, maybe at this location. And then here, after I save the project, I have this option, save record time histories and save mean spectrum. So I go for save record time histories. This option will be there, and it says save data from original accelerogram, save data from matched accelerogram. So I click on matched accelerogram, and then all selected accelerograms can be checked. There is only one accelerogram here which is selected. Otherwise, I can go for specific accelerogram and then RSN 886, which was my accelerogram. Now it says that what should be the format of your file. So I say Seismo signal format, time and acceleration. Okay. So I save it in maybe on my desktop, let's say. So I click on create file, and now you should have a file which should be saved, and that is the matched acceleration time history. So this is my file. It is not showing any data here for some reason. Let me check. Okay, one reason which I also explored, and that was that the file name is too long. If the file name is too long, it will not show, it will not save the data because of that issue. Otherwise, it should give me the acceleration and time values. So let me quickly repeat at the end just to confirm whether this is the reason for that issue. Let me just quickly modify the name of the acceleration time history. I reduced the name. So let me just open single, and then maybe, okay, let's now use some default ground motion. Let's say this Chichi earthquake. So this have a different format. So this data starts from line number 6, and it has two columns. One is time, one is acceleration, and there are 1, 2, 3, 4, 5 rows which are header rows. So first line is line number 6, last line is line number 5284 or already. Delta T is 0.02. No, it is 0.01. So it should be 0.01, and the option should be time and acceleration values per line. Acceleration column is second column, first column is the time column. After putting all these values, I click OK. So this is my original time history. I define a target spectrum. Let's assume that this is the same target spectrum, and I directly click on do matching. Okay. So now it is modifying the ground motion to match with this target spectrum. And this example will also show us the difference in the frequency content of the actual and the modified ground motion. So you can see this is the modified ground motion now, and this is Chichi, this one. So you can go for the response spectra and then comparison. So you can see here that this violet color spectrum is for the original ground motion, and the green one is for the modified ground motion. So now let's export that file, matched acceleration time history. So I say save record time histories, and I say that okay, let's select all selected files, which is the Chichi one, and time and acceleration should be saved. And I click on create files, and I selected save data from matched accelerograms. So I click on create files, and a new file is created on my desktop. Let's open it now. See, and now it is showing me the acceleration and time values for this particular earthquake. So you can see here, this is the whole earthquake data. So it means that the acceleration time history, the format of acceleration time history will be modified once you use the Seismomatch for spectral matching. But whatever format you have, you must understand it first so that you can import that in eTabs later correctly. So that's all about the spectral matching in Seismomatch. Now let's towards the end see the option for spectral matching in eTabs. So let me open eTabs first, and then we can see the option which is available in eTabs for Seismomatch, the spectral matching. Uh, one one issue in eTabs is that it doesn't allow us to export the matched file as a text file outside the program. Just like in Seismomatch, we have done it that we have actually exported the modified ground motion as a separate file, which we can import it in any program like eTabs to perform the time history analysis directly. eTabs doesn't allow us to export it as a text file. So resultingly, we cannot plot the spectrum of the modified ground motion ourselves. Here we can plot it ourselves. We can go for response spectra, and then in the table form, I can copy the response spectrum of the modified ground motion and plot it myself. And I can overlay it on the target spectrum myself, and I can plot all of these graphs like this, which I have shown you. I can do it myself if I export the time history as a text file, or if I use the Seismomatch. But if I use eTabs, it will not give me the text file or spectrum of the modified ground motion. It will show me, but I can take screenshot only. I cannot take out the values. So let me go to eTabs now. This is eTabs, and I will just show you that option which can perform the spectral matching. So I will click just new model, and just go with the default units and other settings. So I click just OK, and then click on grid only. So I will directly go to define, and then functions, and then time history. And in time history, the very first step I should do is that I should go for from file option, and then import one ground motion. And after that, I can go to this second option, which is match to response spectrum. Okay. So let's first define from file and click on add new function. And then I can click on browse here, and then I can select the ground motion file. So let's say that this is my location where the ground motions are saved. So let's say these are the ground motion files. This is the one which I just downloaded. So I click this file, and nothing happened because I have to provide these values first so that the program can actually understand the format of the file. So the header lines to skip, let me just open that file also. There should be first 4 lines which should be skipped. So in Seismomatch, the option was first line. So I should give basically line number 5 here. But here the option is number of lines to skip, header lines to skip, so I should say 4. Now there are, when I click 4, the graph appeared here, but let's check other options also. Prefix characters per line to skip. There are some ground motion files where there is a prefix character before the start of each line, but here we don't have any, so we will just say 0. Number of points per line is 1, 2, 3, 4, and 5. So we should change that 8 to 5. And then the last thing is values at equal intervals of 0.02. The first option is time and function values. If you have one column for time, other column for acceleration, go for the first option. But if you have the acceleration values only, then go for the second option. So values are at equal intervals of delta t equal to 0.02, which is correct. our delta t is 0.02, and then free format. So I will click OK here, and now this file is imported. Okay, this is my function file. Now what I can do is I can click on view response spectrum to see its original response spectrum of this file. So these are the response spectra for different damping ratios for this particular earthquake, and I can just see them. These are the different damping ratios. I can click OK. Now let's spectrally match it with a target spectrum using ETABS. There is one first we have to basically define a target spectrum also. So let me just click OK here and go to define functions and response spectrum, the first option. Previously I was in time history. So I click response spectrum, and I have to first define a response spectrum, add new function so that it can be used as a target spectrum for that ground motion. So I can select from a list of different codes, and I can also go for from file. It will read a file which I can just import, and I can select from, I can also go for user option. User mean that I just point by point add the response spectrum. And if I go for user option, I have to give periods and the spectral acceleration values. If I go for from file option, this one, then I have to give a particular file by clicking on browse here, and then it will plot, it will read that file, and then it will plot the acceleration target spectrum. Let's, for the sake of this demonstration, quickly, let's select one particular building code. Let's say UBC 97. So UBC 97 is added, and click on add new function. Now all the input parameters required to construct the spectrum using UBC 97 equation should be given here, and there are two parameters which are for your site in UBC 97. One is called CA, other is called CV. We can give their values, and the program automatically plots the spectrum. If I select ASE code, for example, let me select ASE 705, add new function, then I have to give SS and S1 value. So this 0.2 second spectral acceleration is SS, 1 second is S1, and this is TL, long period transition period, TL. And the last thing which I have to give is the site class. All other values I cannot change, they are automatically calculated. And finally, using the equation given in ASE 705, the spectrum is plotted. So let's use this spectrum as our target spectrum. So let me call it as my target RS, and let's save it, click OK. We can also convert it to user defined. If I click it, it will just give me these two tables, this two column, and then all of the background information will be lost. So if I click on convert to user defined, it will be all, it will just pick all these values of time period and spectral acceleration and define as though I have just defined it like a user defined response spectrum. Anyways, I click OK, and target response spectrum is defined already. I click OK. Now I go back again to the functions and time histories, and then now I have already one ground motion imported, original as recorded ground motion. I go to match to response spectrum option, the last option, and click on add new function. Very first thing I have to give is the name of the modified ground motion. So I say that modified or spectrally matched ground motion. And then there can be spectral matching in frequency domain or in time domain. There is a slight difference in the results also. Now this is the important option. Target response spectrum. From the list, you select your response spectrum which you have just defined. And reference acceleration time history, you select that acceleration time history which you have just defined. Okay. So now this is your target spectrum. This is your original time history, and you just have to click match time history, and it will quickly modify the ground motion and match with this target spectrum. So one thing is that you please make sure that the units are consistent. They are the same units in which the acceleration time history and the response spectrum is defined. So response spectrum was defined in G units, and the acceleration time history was also in G units. So both are correct. So I will just quickly click on match time history. When I click, you can see here that the ground motion is modified now. The original ground motion had the blue spectrum, which is very low, and the modified ground motion have the red spectrum, which is now matching with the target spectrum. Similarly, here is a comparison of blue and red time histories. Blue is very low, which is very small. It is the original ground motion, and red is the modified ground motion, which is after spectral matching. And you can also convert it to user defined. You can also see the frequency content, which means the Fourier spectrum. So this is the Fourier spectrum of the original ground motion, and on the right hand side you have this frequency content of Fourier spectrum of the modified ground motion. So if there is any difference, you can identify from here. And if I click OK, the modified ground motion will be saved by this name, which is based on this original RSN 886 Lander's ground motion. So we can use the modified ground motion, this name, for the time history analysis, because this is already modified. I can click convert to user defined also, but I will directly click OK now. And now modified ground motion is saved. Okay. So now this ground motion modified GM, this should be used for the purpose of time history analysis. So I click OK. And when I make the load case for time history analysis in the define load cases, and let's say that I want to add a new load case here, and I want the time history load case. And in that, I will add this one as the acceleration pattern, and the function will be now modified GM, modified ground motion. Okay. So this function will be used as an acceleration function, acceleration time history, for the purpose of time history analysis. So that's all about the spectral matching in ETABS. So let's end this session here.
Yun po, dun na po, nakita niyo naman ko po kung paano po in-apply yung spectral matching po sa ano po sa ETABS. Yung pong ETABS ay isa po sa applications na ginagamit po. Yun lang po.
Thank you. Actually, yung incomes, yung staan din siya. Pero sabi mo, napakarami software na ginagawa sa structural design. And I think yung staan, i-introduce in. So guys, ito yung link. Spend time na lang to watch. Very informative yung seminar. So for the special moment na 16 frame, ito yung time kung saan i-skip mo yung video para direction kayo sa mismong discussion. And for the geohazard, deleting settings, ito siya. Hindi pa naman siya next week ipapasok. So dalawa yan. Right? So next week, guys, ready yung susunod na reporter. And siguro yung first 1 hour, ako only mag-discuss about sa MSAP 2015. Mag-secure na kayo ng copy. Tapos, ayun na. I-try kong i-upload kasi medyo malaki yung file. I-send ko lang sa MCU yung link para ma-download yung copy. Alright? So again, na-receive nyo naman yung term grade. Ang nangyari kasi dyan, isinet ko muna guys na 85 lahat yung sa reporting. Pero possible na tumaas pa yun. Kasi ayun nga, meron kasi ibang hindi pa nakapag-report. So, ayun. Okay naman. Meron na lang ilan. Ayun naman. Ano ba ito? Ma-attend or hindi. Pero again, wala naman babagsak dito sa number lang. Okay, so yun lang. Thank you. So, pa-copy na lang itong link na to. Tapos, panoorin niyo ng material. So, see you guys next week. Again, reporters, be ready by the talk. You will have a good